So now I want to drill down a little bit into what do the PDF and the CDF look like for a discrete random variable. So I mean two discrete random variables. And I guess that technically we talked about, in the discrete world, we talked about PMFs, right? So what do the 2D PMF and the 2D CDF look like? Okay, so we're going to follow our nose and do it exactly the same way that we did it for the one-dimensional case. And to motivate it, let me just use an example of flip a coin 5 times and let X be the number of heads and let Y be the position of the first head. And since it's possible that I may get all tails, let's just say it's 0 if there are no heads, okay? Just to make this well-defined, okay? So let's think about what does the PMF of this look like, okay? So following our intuition, the PMF is, we're going to call it little p of xy. This is the probability that the random variable takes on each of these values, okay? Now, let's think about it. We flip the coin 5 times. There are 2 choices at each time. So I have 2 to the 5th equals 32 possibilities, right? So one way I could do it, which is kind of tedious, is to enumerate all the possible values. And I'm not going to do that right now. But I could have, for example, all tails. I could have 1 head, and so on, all the way to getting all heads. And so what I can do is I can plot on a graph what are these probabilities, okay? So let's say X and Y, okay? So X is the number of heads. That could take on values from 0 to 5. Y is the position of the first head. That can also take values from 0 to 5. Okay. Now I'm going to let you think a little bit about what are the values here. I'm going to put them in with a couple of examples, and you can think about why these make sense, right? So for example, the probability that I get 0 heads, well, if X equals 0, then Y is also equal to 0, right? That's like the probability of getting tail, 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 tail. The probability of that is 1 over 32, okay? What if I only have 1 head, okay? Well, there are 5 ways that can happen with the head in each of these 5 possible places, right? So I'm just putting dots where there is non-zero probability happening. The probability of each of these situations is also 1 over 32. What happens when I have 2 heads, right? Well, that's a little bit harder to think about. So in this case, 2 heads, how many ways are there for that to happen? Well, I have 5 to choose 2, which are 10 possible ways that could happen, right? And of those, I have to think about what are the possible values for the location of the first head. So now it's not possible for the first head to occur on flip 5, because if I have 2 heads, the latest it could possibly be is flip 4, right? So I have 10 possibilities, and I have to think about how do I allocate the probabilities among these 10. Well, a little bit of thought will lead you to the fact that it's least likely for me to have a situation like this, and that has probability 1 over 32, and there's only one way that can happen. But there are actually 4 ways it could happen for me to get the first head on the first flip and still have 2 heads total, right? There are 4 possibilities. So basically, I have these probabilities, 4 over 32, 3 over 32, 2 over 32. And then, just to make this video not last forever, I'm just going to mark down what the rest of these are. This goes like 1 over 32 down the diagonal. This is 3 over 32. This is 6 over 32. And this is 4 over 32. And so I should convince myself that these numbers all add up to 1, right? So I have basically 1 plus 5 plus 10 plus 10 plus 5 plus 1. So I have 10 plus 10 plus 10 plus 2 is 32, right? So Again, if I'm being really precise, I should really think about these things, if I'm talking about the same way I talked about in 1D, I should really think about this like a bunch of delta functions coming up out of the page, right? Because as we'll see, the concept of continuous random variable PDFs is going to kind of subsume this idea of discrete random variables. But it's a little bit tedious to think about drawing these arrows in 2D. So I'm just going to draw these like dots with probabilities. Okay. So now if I wanted to look at the probability of a certain event, like say, for example, the probability that I got less than 2 heads and the location of the first head was at least number 3, I could look at just a region of this and I could add up the non-zero probabilities that are inside that rectangle. Okay, so how would I get the CDF from this PDF? Okay, so again, even harder to draw, but the CDF, let's remember, is the probability that x is less than or equal to some value and y is less than or equal to some value. So it's like saying, okay, for each point in the plane, and this could be for any continuous number, not just a discrete value, for any xy, I'm adding up all of the dots that occur down and to the left of that point. Okay, so it doesn't take too much thought to convince yourself that the CDF for this example will look like kind of a 2-dimensional stair-step function. So again, here's 0, 1, 2, 3, 4, 5. So it's kind of like going to be a series of cells. And each cell, I have a probability. So I know that out here, I have 1, right? So I know the probability of being anywhere less than this number has to subsume all the probabilities. Anywhere out here is 0, right? Anywhere outside of my graph is 0, okay? Question is what goes inside here. So what I'm doing, I have to look back at my graph and say, okay, well, what's the probability that if I'm looking at this cell here, what's the probability that I'm underneath this shaded area? It's 1 over 32, right? And to make this a little bit cleaner, I'm just going to draw this, divided by 32. So I'm just going to put an integer in each of these cells. Okay, so this is 1 over 32. And actually anywhere, if I think about any point in this left-hand cell, the only thing I'm going to catch is this dot, right? So actually, I'm going to get 1 over 32 everywhere I go over here. Okay, and so what about in this part? Actually, the same thing is true. The only dot I'm going to catch is 1 over 32. Now let's suppose I skip over to this cell and I look at how much have I caught here. Well, I'm going to catch this and this. So I have 2. And if I move up 1 click, I'm going to get 3, 4, 5, 6, right? So I can kind of start to draw my dots in like the following. Okay, I'm pausing for a second because I feel like, oh yeah, this is okay. So, after I get beyond this point, I get 6. So I guess I really should be drawing in what happens at the edges. Okay, and I can actually think about this big 1. I'm going to turn this into a 32 because now I've divided everything by 32. Okay, so what happens if I skip along the bottom here, right? So I'm going to have 1 plus 1, then I'm going to add 4, 6, 4, 1. So I'm going to have basically 2 plus 4 is 6, plus 6 is 12, plus 4 is 16, 17, right? So I'm going to have 2 plus 4 is 6, plus 6 is 12, plus 4 is 16, like this. And so it's a little bit tedious to fill out. I'm looking on my notes to see if I actually have the full thing written down. I believe I do. Yeah, here we go. So let me write down what the whole thing looks like. And even this is pretty tedious. I mean, to be honest, I wouldn't ask you to write this in any detail on an exam. And even on a homework, it's a little bit like busy work. Okay, so the CDF is actually, the way to think about this is it's actually like this stair-steppy function that gets a little bit bigger at every step, right? And I'm drawing it kind of poorly, but honestly, this is the best I'm going to be able to do with paper and pen, right? So really, you should think about this as kind of like a bunch of apartment blocks that are rising out of the paper, and the height of the apartment block is this thing, right? And again, this kind of confirms the idea that after I top out at past 5 on both random variables, I've accumulated all the probability, okay? So a little bit tedious to do with discrete random variables. We're not going to do it very often, but now let's talk in the next lesson about how does it work for continuous random variables.